it's your first time joining us, my name is John Quijan. I'm a professor at Howard, and I'm the program director for this training. So today we are going to continue with the module instructions. Last week we completed data preparation, exploration, and visualization. Today is going to be classification modules. But before we start, a few announcements. If today is your first time joining us, they will post pre-training survey in the chat area, and I believe that also in Slack. If you haven't completed it, please take a moment and complete that for us. And also, I think I said from the beginning that this year's training, basically the exercises that the instructors for each module will give you. So you want to complete those, and then you can send out to VADSTI at howard.edu. The instruction is posted in Slack, so you want to check it out and then do so. The instructors use data set that they came up with or found somewhere. But if you want to use your own data set, that is fine. Just follow the instructions. You can even change the variable.
Yeah, John's voice is breaking up.
That the instructors gave you, you can decide to just compare that you want to evaluate. Can you hear me loud and clear?
Yeah, but your audio is breaking up from time to time.
Can you hear me?
Your audio is breaking up from time to time.
Yeah.
Let me call John. I think he's having some connection problem. Nana, is John next to you?
I'm sorry, are we waiting for someone?
John was saying something, and I think he got connection problem. Okay, so he said we can start it. Right. So hello everybody. Welcome to our classification model. This is John calling. Yes, John. Okay, hi, thank you. Yeah, John got disconnected, but he will be in shortly. Let me turn this off. So before I start with today's lecture, I still want to share Howard University free data science course. If this is your first time, it's a linear algebra for data science using Python specializations. Right, it's free, 100% free anywhere. Right, as long as you got access to the internet. Right, so my colleague Dennis and I have this on Coursera. Right, we got so far 721 students. So it's once you complete the capstone project, you will get a certificate from us. right? And the capstone project is at mod 4. To be able to complete that, you do need to go through mod 1 up to 3. Okay. So again, welcome to our classification model. The first model that I want to discuss today is logistic model. Let me see if can you see my PowerPoint slide? Can you see my PowerPoint?
Yes.
Okay, good. All right.
Yes.
So let me move these out of my PowerPoint. Yeah, so logistic model is one of the method, right, the data scientists use to classify a data set, or to use a classification problem. So in this lecture, we are going to discuss logistic model. How do you use a logistic regressions to solve a classification problem, and how to interpret the results of a logistic regressions. So to do this, we will be using either confusion matrix or I think confusion matrix would be a good way to go, right? So to check how good our model was, right? So like I said, we're gonna do classification model, logistic model today, and then we're gonna interpret it. So we want to build a logistic model as a method of classification here today, right? So like in machine learning or statistics, classification model trying to classify the next step, the next output, which category it does belong to, right? Based off the training data, right? Some of the examples of classification problem include when you're trying to detect spam, versus ham email, right? Or whether you're trying to predict, if someone will default, to pay pay back their loan, right? Or either you're trying to predict whether or not, someone has a disease, right? Given, a data set, right? So pretty much logistic regression allow us to solve classification problem where we are trying to predict, right, discrete category. So 1 and 0. By convention, 0 mean no, 1 mean there is a presence of it, or positive, 0 negative, right? So these are some examples that we're going to discuss. But as you can see, in classification problem, you cannot use our normal regression, linear regression model to fit the data set, right? So this data set, I don't know if you can notice the orange, we got one data set that is at 1, the other data set is at 0. Think about this as a probability that someone belongs to a group. So think about it as 2 groups. The top group is the probability that that person, 1% mean the person have 100% to pay back a loan. So you belong to that group. And the bottom line is the probability that someone will be able to pay that loan. But 0% probability means that person has no chance at all, right, to pay back this loan. However, if you're trying to fit this data with a linear regression, you see this in blue, it will not be beneficial. In fact, it will not lead to a good fit if you look at it, right? If you check the bottom below this line, you end up having some negative probability, right? Which doesn't make sense. And then you are missing all these data points from the top, right? So that's why logistic regressions is needed, right? So this is what logistic regression look like, right? So it is the main, the most popular one is a sigmoid function that is defined like this, which is 1 over 1 plus e to the negative z, right? So we can transform this. Why so? It doesn't matter. I'll tell you why. If you look at this function, it doesn't matter what value of z what value you give it to z, this sigmoid function will always be between 0 and 1. No matter how big z is or how small z is, whether or not z is positive, negative, this function will always be between 0 and 1. So that means we can also squeeze in our linear regression model in the sigmoid function. So instead of having 1 plus e to the z, we can replace that z, right? Because z can be anything, we can replace it. So by a linear regression model like this, right? So by convention, a linear regression model is y equal b0 plus b1x, right? So in algebra, they call this one y, slope intercept form. The slope is b1 and then the intercept is b0, right? So again here, regardless the value of b0, b1, x, this sigmoid function will always stay between 0 and 1, right? So the logistic curve can only go between 0 and 1, right? You will never see a logistic curve that go beyond 1 or below 0. Let me see, I got some messages here. Okay. All right, so these are not for me. Okay, so if you look at this, we said this curve is trying to fit a data set where in that data set, we're trying to classify people into 2 groups, right? And then the function is between 0 and 1, and then half of it is 0.5. So we can use 0.5 as a cutoff point, right? So anything, right? Anything that is below 0, right? Let's say 0.49, we will say that those people do not have a chance to pay back the loan. So they will belong to the class 0, right? And then anything above 0.5, let's say 0.51 up to 1, those will belong to class 1, people who will be able to pay back, the loan, right? So that's the cutoff point, very important, right? So we'll make our decision based on that. If you're less than this, you belong to this class. More than this, you belong to this class. So that's how you will classify, right? Okay. So model evaluations. So once you run your model, you definitely need to make sure that the result of your model makes sense, and then the model is doing a good job. So like I mentioned earlier, one way to validate that is to evaluate or check the confusion matrix. So confusion matrix is just a table that is often used to describe the performance of your model, logistic model, right, or random forest model, and so on, right? So what is it? So let's give you an example here. Let's give an example here. Let's say you have this. You have a total number of 170 patients, right? For example, and then out of that, you have actual no, let's say a specific, let me see, please remember, okay, that's my name. So this table here, the actual no that somebody does not have that disease is 55%, right? So this is the actual no, 55. And then we predicted a no. Our predicted node was the actual node was 55, and our predicted node was 55. And the actual node, among that, we predicted that 10 of them were yes. So we call this one false negative, right? It's a false negative because it was a no. This 10 was no, but we said no, they were yes. So actually yes, right? So here we accurately predict, right? We accurately predict 100 of them that were accurate, right? And We predicted the 5 yes, however, there were no, right? So our prediction was no, but it was yes. So this matrix will really allow you to check how accurate, how perform your model is. So these two are true. So this is a how do you call it? True negative. This is a true positive, right? This is a false positive. This is false negative, right? So let me see. I think I have it in the next one. So what you will do, you need to figure it out. For example, the precisions, right? The precisions is the actual true divided by the total number of true, right? So let's say your model predicted 100 of them, but there were 105 true. So that precision will be 100, right, divided by 105. Let's see. So negative test. So 0 for no, 1 for yes, right? So like I said, with true negative, right, there were negative true of them, we got it right. So that's 55. And then true positive, we got 100. False negative, right? That is this. We got this negative, but they were yes. And then we got false positive here, right? We said they do, but they do not have it, 10 of them, right? So the total predicted here, no, was 60. The total predicted here was here 110. So true positive, we already defined that. Now, how you define the accuracy, right? So the accuracy is equal to the true positive, what the model got right. So the model got true positive right, and then true negative right. So those are correct. So in our case is the 55 plus 100 divided by the total number of an individual, right? So that's the model accuracy right there. So the error will be the total error that we make. So 5 plus 10 divided by the total numbers, right? So let me see. So we got 9% wrong, 91% correct, right? That's what confusion matrix allow you to do, right? So you definitely need to print a confusion matrix after you run your models so that you will be, have some confidence in your model, right? If this is too bigger than this, you know that you need to do some data engineering or you need to change model, right? Okay, so now I want to go back and then use a real data set, right, to run a logistic model. And then once I run the logistic model, then I will also print out the confusion matrix. And once I got the confusion matrix, then we will see if our model was performing enough or not. So, but before I do that, I do want to mention running a model is like a 5% of data science job, right? Running a model is 5%. Let me see, stop this. So the most important part, I would say the heaviest duty of a data scientist is data processing, right? So if you put junk in the model, then you will get junk back. Like they said, gotta be in, gotta be out. So you gotta spend a lot of time first working on data. Machine don't know letters, so make sure you change category to dummy variables, nodes, take care of the noise in the data, and then normalize your data and so on, right? So this is the most important part of a data science job. data processing, right? In today's lectures, I will not focus more time on that, but it is very important to know processing data. So I just want to mention some of them. If you never heard this, encoding, right? So you have a categorical data, cat, dog, bird, yeah, you put in the machine, it doesn't know, you get a bunch of error. So you can use something called encoding label encoding, right? But the danger of that, you might think that bird is more important than dog, and then cat is more important than dog, which doesn't make sense, right? These are categorical data. So to avoid that, you can use something called one-hot encoding, right? And another method of processing is normalizing your data. This is important. Let's say you have a data set. Inside a data set, you have one of the column, represents income, and one of them represents age. You know that the age column value would be much, much less than the income column, right? And then if you just use the raw data and then perform your machine learning model on that, the income might have more weight, and then it might corrupt, the result of your model. So normalization is very, very, very important in data science. So, right. And I think I use min-max here. So here I take the data point minus the minimum. So let's say 3 minus the minimum here is 3, right? So 3 minus 3 is 0 over itself. So that's 0. So here at the 10 minus the minimum is 7 over the difference. So you do that, and then you get this result, right? 5 minus 3, right, is what? 5 minus 3 is 2 over 7, right? You are dividing by the difference between the minimum and the maximum. The difference between the minimum and the maximum is 7, because the maximum is 10. The minimum is, what's the minimum here?
We're still seeing your PowerPoint presentation.
You cannot see?
We see the last slide on your PowerPoint presentation.
Oh. Does this say processing?
It's showing slide.
I think you have to unshare and share again.
Okay. Yeah, I'm still on the slide. So the question is, what slides are you guys on? Does it say processing?
No.
Okay, so okay, so current slides.
If we can go back about 3 or 4 slides, that'll be good.
Okay, I don't know why it's not even showing my slides. Let me close this out, minimize it. How can I do this? Okay. What is a Zoom? Okay, I want to share it again. Okay, can you see now? Can you see?
Yes.
Oh, okay, so this is what I was here. So what I'm saying here, let me see if my pen will work here. So I'm saying here, here's my pen. So I'm saying what I did I did the X minus the minimum over the maximum minus minimum, right, to normalize these. So if I take 3 minus 3, the minimum is 3 over 10 minus 7, 10 minus 3, so that's 0, sorry. And then if I pick 10 minus 3 over 10 minus 3, so that's why you got 1. If I pick 5 minus 3 over 10 minus 3, which is equal to 2 over 7. That's why you get this. So this is one way. I know you got a lot of way to normalize your data, but this is very important step. NAN to get rid of the missing data. So here, I think I replaced the missing data by the mean, right? You gotta check. Sometimes the mean could be a bad choice because the mean is sensitive to the outlier. Sometimes the median might be, a good choice. But in scenario, let's say you have a data of student, and one of the age is missing. So in that case, it makes sense to replace the median age by the mean age of the class, right? Because people, from the same class usually tend to have almost the same age, right? So in that case, the mean will work. But things that income, stuff like that, you might have outliers. So be careful with the mean. The median might be a good choice in that scenario.
Dr. Musa, what is 0, 1 means here? 2 and 3, 10, 5, 7?
0, 1, yeah, I linearize it. That's what I was showing in red. So to get 0, what I did, I look at the minimum from this column. What's the minimum? So 3, I'm changing 3 to 3 minus the minimum. 3 minus the minimum of all the data. What's the minimum here? It's 3. So it will be 3 minus itself over the maximum. What's the maximum here? 10. So 10 minus the minimum. So in that case, you get 0 because the minimum was 3. Right. So I normalize this brown column to get the green one. Right. To get, for example, 0.3, to get that, you do 5. Let me see, I can write here 5 minus minimum. Minimum is 3 over the maximum minus the minimum. The minimum is 3, maximum is 10. So you get 2 over 7. That's why 2 over 7, you can check. I think that's 0.3, right? That's how I got that.
Dr. Musa, I have a question.
Yeah.
So under normalization, why is it that in the under row, the dog row, there's a 3, and then in the third row under dog, there's a 5? Like, are these just random numbers that you?
Yeah, these are just a random number. They're just random number.
Okay, thanks.
Yeah. Yeah, just random number. Okay, so these are not all of them, or model selections. So here we drop one of the columns, right? Why? So there's, as a data scientist, you should justify why we don't need these columns. There might be the variance inflected factor might be one of the reasons. For example, if you have the first column represent the years of the car, and then the second column, let's say that represent the mileage. The mileage and the years of the car, the variance inflected is much, much, much greater. So you don't need both of them. Why? Because a newer cars tend to have a lowest mileage, right? And then a car that have a more mileage tend to be older, right? Even there, there might be some outlier. Right, so you don't need both the years and the mileage of a car. You drop one of them. Right. And feature selection also, very important thing, right? so that you'll be able to get beneficial information from the data. Right, the data comes in all kind of shape. Right, usually there is no trend, no normalities, no linearity. It comes from all type of data is going all type of directions. But with recent technology, you can work on the data set to extract information out of it. So that I wrote down here, and I don't know how to erase these. Right. So scikit-learn, all of these, the good news is that all of these libraries are available on scikit-learn, right? Already. So scikit-learn, the pre-processing. Right. So here I did imputing. So scikit-learn, the impute. Right, scikit-learn the feature selections, scikit-learn that feature extractions, right? You can go to scikit-learn website, and then right, you can see there are so many of them. So data processing is very, very important. You have a nice data coming in, yeah, your model will do a better job. But if trash, then don't expect the model to perform well. So once you clean your data, you normalize, you do everything that you're supposed to do, then you can think about modeling. This is the last part. Modeling is really icing the cake, right? They're already there. Just call them, and then divide your data set into training set and then the test set, right? You train your model on the training set. Once you get it, the model gets familiar with the data set, and then you will see if the model can predict, right, or the Y test using the X test, right? And then you will predict, and that prediction, you can compare it up to the actually Y test. And the difference between your prediction and the actual data set is what we call the cause or the error. I think that's some message here. Okay, all right. So I wanted to mention that. Right, feel free. I really want everybody. I encourage you to check this if this you're not familiar with scikit-learn. These are very beneficial libraries that every data scientist should be using. So now let's go back to real world data set. Right. So to demonstrate today's logistic model, or to demonstrate our logistic models, I will use a very famous data set called Titanic. Right, it's very famous. If you go to any data bootcamp, you will be studying Titanic data set. So let me see if I can get to my Jupyter notebook. PowerPoint on. Okay, Jupyter notebook, logistic model. So can you see my Jupyter notebook? Can you see my Jupyter notebook?
Yes.
Okay, so first thing we need to do is to import libraries, right? So I want to import, I know that for sure I will be transforming my CSV data set into a Panda data frame. So I will import pandas as PD, right? And then I will import NumPy, right? I will be doing some calculation maybe. So it's safe to import NumPy as PD. And then I will import matplotlib, import matplotlib, that's pyplot as PLT.
Dr. Musa, check the short form of NumPy.
Oh, NP, thank you, as NP, thank you, appreciate it. As NP, and So I want to import Seaborn also. Import Seaborn. Again, Dr. Abel gave a nice presentation on data, exploratory data analysis. So I'm not gonna, pay a lot of attention on visualization today. I just want to wave my hand, but I'll do a couple of them because we need to see what kind of data we're dealing with. So Seaborn as SNS. And yeah, I think that should be enough. Let me import, these are visualization library, by the way. So just in case, let me import PyLab. All these PyLab as PL. Also, yeah, that's it. All right. So I have these. Now I'm ready to import the data sets. So this is the data set that I got from here. Scikit-learn Python libraries, the function easily allow you to normalize data set. Okay, so. Okay, so now, in case you don't know, this is what I got the data set from. Let me do this. I'll share my whole window so that if I keep changing window, you still see. Can you see this, everybody? So what I did, I went to, can you see this thing here, Kaggle?
Yes.
This website, can you see Kaggle?
Yes.
Okay, so Kaggle is a place where you will get variety of data set, right? If this is your first time, feel free to sign in, have an account. And then there are two things you can do on Kaggle, right? You can get data set, like I can type here, Titanic, you see my search here, Titanic data set, and then I can browse through all of these are Titanic data set. And then I will click on the one that I want, right? I can click on this one and then download it, right? It's on data, make sure it's data. Sometimes it will be on notebook. And then click on download it. Once I download it, then I will drag it and paste it to wherever I want, right? I'll drag these and then put it to a folder that I want or in my desktop, right? So in addition to downloading data, there are competition also on Kaggle, right? That you can participate, right? See all these competition, you see the money? So if you win, you get this money. Most of the time, company also post those competition. If you end up being among the winner, then they will call you for an interview, right? So I don't know if I should put a Kaggle on the chat. And let me do it in case somebody, this is somebody first time to hear it, right? So I got this set from there. It's very famous. You type Titanic data set, you will get it. And then drag it and paste it to my VADSTI folder because that's where my Python is. I will open my Jupyter notebook. So the Jupyter notebook and the data set must be in the same folder. Otherwise, your Jupyter notebook will not see the data set. So I did that already. So I'm gonna load it. I'm gonna convert that data set into the CSV file into Titanic. I'll call it Titanic. Titanic data frame is equal PD. So I'll just import panel that read. So if I said that read and then hit tab, you will see there are a lot of options. So you can read clipboard, CSV, Excel, others, you can name it, HTML, JSON, and then so on, XML. So here I'm just doing CSV, right? I select that because my file is a CSV file. And then the name, I believe the name is Titanic also. I save it at Titanic.csv. So if the name is incorrect, I'll get an error message here. Okay, so let's see. Just want to take a look, right, to check the first 5. So here I'm checking the first 5 rows of the data set. of a data frame. Right. So I'm checking the first 5 rows of the data frame by using the head method, right? So using the head method, that's it. So I'll say here Titanic, right? And I hit tab, it will auto-complete it. I had, this is the data that we're dealing with, right? Okay, so you have passenger ID, it has survived, class, sex, and you can see, right? So one thing I want to do is to have some idea about the number of rows, number of columns. So I can do that using info. So that info, right? So it's saying that I have 891 rows, right? And then 12 columns, right? So you also tell me what type of data I have inside here. So this data, we are lucky, this data are almost clean for us, right? But in reality, in real life, you don't get clean data all the time. You have to do a lot of work, right? So if I look at the age column is a float, the total row is 891, but look at the age column is 714. So that means the age are missing, the age column are missing some data, right? So we need to do something about that. And the cabin also, cabin almost 3, almost more than half is missing, right? Maybe we can get rid of this cabin, right? If it doesn't help us to identify, to classify, survive or non-survive, right? So this is our classification class. We want to classify, whether or not somebody survived or did not survive. After classification, we want to see how much error or how much, our machine was able to accurately predict, right, that someone survived when in fact they survived, or someone didn't survive when in fact they didn't survive, right? Okay, so I have that. And one thing I can do here is to drop some of the feature. I don't like the passenger ID. I don't think that will do something important. So I want to drop that. And I can also drop, let me see, DF. I want to drop passenger ID. And then at this point, you should have some reason why you want to drop them. To me, the passenger ID will not help me to determine whether or not somebody survived or not. I know the class you are in really, will determine whether or not you will survive. The sex also will be something that determine, that's a factor that determine whether or not you have a chance of surviving or not. And maybe the cabin that you are in, right? So, but passenger ID, I can just drop that. So I want to say, I want to drop passenger ID, also ticket, right? I can drop tickets, but someone might argue that the ticket also might be a factor to determine, because those tickets got a value, right? The highest, the ticket is, the more likely that person is in the first class, and then those first class are more likely to survive. So in any way, this is just an example. Let's see, this is how you drop your passenger ID is right here. This, I'm gonna drop it. Right, so dropping it, and ticket. Yeah, I want to drop these two. Right, otherwise I have to do some cleaner on the ticket, because you have a alpha and character, and then ticket here. Right. So once I do that, I have to specify that I want to drop the entire column. That's axis equal 1, the entire column. And I have to also make it permanently, right? For example, if I just do this and then run my Titanic DF again, that head, you will see that they are there. Passenger ID is still there. You drop it and then automatically came back. But if you don't want it to come back, then you have to say in place equal true. In that way, the change will be permanent, and then you don't see passenger ID anymore, right? So name, right? Name could be something that we can drop, right? You can change the index, but I'm not interested in that. So now let's look at this thing, the mean age, right, of this survivor. So survivor by sex, for example, we can do a plot. We can do a count plot to look at it, but we can also look at these group by sex. So we group by sex. So that group by, and then we put here sex, and then we need to take the mean. That mean, if we do that, what do we get? By the way, if you don't, group by always followed by an aggregated function. Let me take this out. If you run this, it just give you group by object. So you need to either find the mean, the median, the maximum, the average. So group by always followed by an aggregated function. Otherwise, you just get a group by object, right? So here, female have 74% of females survive, right? Only 18% or less than 19% of for male survive. You can see that from here, all right? So P class and so on. But P class is funny because we got 3 classes there, right? And then the mean age of female were like 28, and then for male was 31. Sibling, right? So the mean was, this makes sense, it was 0.69, right? So sibling or spouse, that's SBSP stand for sibling or spouse. So here, in the upper class, if you dig more, you will see that in the upper class you got as this number is higher because upper class they're richer, most of them are accompanied by somebody that can pay, or their spouse. Right, but lower class, this number is even much lower. Right, they're just single men trying to come to America. Right. Anyway, like I said, I don't want to spend too much time on exploring visualizing stuff like that. One thing you can do, you can also check this. I said here, age less than 18. So what you can do, those you want to know the survival rate among children, for example, right? Again, you can differentiate that by class and then by sex also. So you can write your Titanic DF. So you will be acting on the Titanic DF at the age column, right? So age, yeah, come on, age. So I'm grabbing the age column. And then I want the age to be less than 18. So those minor. And I want to group by. So group by. So here you can group by more than one feature. So I want to group by sex and P class. Sex, comma, P class. Right. And if I run these, I only get a group by object. But if I take the mean of that, or the average, or the maximum, or the minimum, right, I'll get an output. So mean that. So let's look at this. So 88% of female in the first class survive, right? 100% of female in the second class survive. 54% of female in the third class survive. Look at men. Male, so 100% on the first class. So the age column has some nulls, right? I'm pretty sure the men, if you clean the age columns, if you clean it, this will change a little bit, right? And look at the third class. The third class, male in the third class, only 23% of them survive. Right, so if you are a male in these boats and you were in the third class, the chance that you do not survive was about 76% or 73%, right? So we can look at it by doing a histogram plot. So one way to do that is to just call the hist. So our Titanic DF. So that at age, we want to grab that age and then that hist. Right. So here I want to specify the number of bins. So if I said bins equal 30, for example. So this is what we get. It's running. Yeah. So you see the majority of people in this boat were between 20 and 30, right? Almost close to 40, right? So that's the age distribution. Again, like I said, the age guide a lot of knows. We notice that from the info, right? There are 891 rows, but the age column only have it's missing about 200 of them, right here. Age column like a 700, so almost 100 and something, right? 714. So we can fill up the missing age, right? We can fill up the missing age. I think I have the missing age. Yeah, right here. So I defined a function called input. So this column has two parts, right? It's a column, so two columns. The first column is the age. You see index 0 is the age. So index 1 is a class. So we pick an individual, right? If period is null, so if it is missing, there is nothing there. And then we want to check this. If the class equal 1, we are going to replace it by 37. 37 is the mean age of first class. 29 is the mean age of second class, and 24 is the mean age of the third class. So if you are in the first class, we're going to replace the missing age by this. If you are in the second class, we're going to replace by 29. Third class, we're going to replace it by that, and then right here. So now we build that function input, then we can apply that to our whole data frame, right? So we're gonna say our data frame at age, so I've changed capital A to lowercase a, is equal our data frame to age and colon that apply our input age. So input age is defined right here. Now, when we look at our data frame again, what is not defined? Let me run this first. Titanic DF is not defined.
You spelled it differently when you created it. I think you added an extra letter in there. If you go up a little further.
Oh, I add the extra.
Yeah, the object. Yeah, you have it. Tita. You have. Yeah, you see how you spelled it there.
Oh, Titanic.
Yeah, so you have
I had to go back. Yeah. I have to go back. Yeah.
Using it the way that you did.
Yeah. Titanic. That's what I wanted to.
There you go.
I was like, Titanic is not defined. So right here, everywhere now. Oh, Lord. Titanic. Yeah, I'm not looking at my screen. Okay, so wow, everything should be Nick. Okay, now, wow. Okay, I think Titanic. Okay. All right. What is my age? Impute age. I didn't get there yet. So you can do this with Seaborn also. I don't know if you want that. SNS.Seaborn. You can do that. Do I have any message?
Yeah, why did you replace age by passenger class?
No, I didn't. I didn't replace age by passenger class. So I look at the passenger class. You can do box plots. You will notice that where is my that thing again? Is it down? Yeah, right here. In the first class, the mean age is 37.
Oh, that's why. Okay.
Yeah. So if you're in the first class, we're gonna replace you by the mean of the age, right? That's what I was saying. Like you have a data about your class, a student in your class. Let's say one of the age is missing. So it makes sense to replace that missing age by the mean of a class age because they tend to have the same age. So that's the logic behind here. So if you're in the second class, right, older people tend to have more money because it takes time to accumulate wealth anyway. So if you're in the first class, we will replace your age by the mean age. And then second class, the mean age of the second class. That's it. That's all we're doing. So now the Titanic, does it work now? Titanic. Yeah. Okay. So if you look at now, it get worse for male. For male, the survival really get worse, right? So before it didn't take those noise in considerations, but we fill up those noise by the mean average, you see, right? So almost 100% of female in the first class survive. Look at the survival rate of male in the first class, right? So you can visualize this also, right? You can visualize it. You can do a lot of stuff. So, but now I want to build our logistic model, right? I want to build the logistic model. Or we can also look at our survivor among male. You can look at the graphically, right? How male, you know, this, what I'm reading from this table here, we can do the same thing using count plot, right? So you can visualize it. Let's say you're presenting it, you can visualize it. So SNS, the count plot, X is the survivor, hue, so I want to separate them by class, right? And then by class, for example. And then we can change these, right? We can change these by hue equals sex also. If you survive, you change it by sex, right? Look at the survivor. So the blue for male, the orange for female. Look at how much, right? So the survival rate, male to female, is 2-to-1. If you look at it here, this thing, right? So let me look at the message. Will we do global search in the replace? Yeah. See what you do. Okay. Okay. I'm hoping that everybody can see what I'm doing right now. Right. So now let's build our model. Right. I don't have noise. Let me look at the model first because it doesn't take those numbers, letters. Let me look at the head of our model here first before we fit it in. So Titanic DF dot head. So I will still mine it. So I'm gonna drop some of these. For the sex, I can use dummy variable for that, but I'm gonna drop the name. I'm gonna drop I'll drop a name. I'll make this one a dummy variable. For the far, I can keep it, but for this guy, I can drop the cabin. Embark, I can use a dummy variable also for that. Right. So let's do. Anybody remember how to drop a column? I want to drop name column, for example. I want to drop name column, for example. We did it today. How you drop a column?
Titanic df dot this one drop name, also drop cabin in bracket column, that way.
Yep. That's exactly right. Right, that's exactly right. So let's do that. So we want to drop. So Titanic df dot drop. So everything that we want to drop will be in this list here. So we got name. After that, we got name. I say I want to drop a cabin. Yeah, too many missing information. Cabin. And then what else? Yes, okay, let's do that. And axis equal 1 mean we want to drop the entire column. Axis equal 1 for column, 0 for rows, and in place equal true. In place equal true. That. So now if we look at the head for Titanic data, so let me just put 2 here. I'm still running. Why is still running Titanic D? Okay, what's the name? Name cabin, not found on the axis. Did I drop it already? I don't think so.
No.
Cabin is spelled like that. Name is spelled like that. And they're right here. Oh, I dropped it already? Where did I drop it? It looked like I dropped it somewhere, but I don't see it. I dropped this. The name was still there, right? Okay, now I gotta start over. Right, so clear this info. Yeah, name is here. Yeah, got this. Now it works. Okay, so because I didn't drop early. I don't know why it was still showing that. So this is a categoric. This is category sex and embark are categoric. So we need to change them to dummy variables. Right, so dummy variables. Yeah, so let's change those to dummy variables. Dummy variables. Dummy variables, right? So we can define a variable called, so there are many ways to do this, right? You can just, okay, let me do it this way. So I will define a variable called sex, and I will say is pd.getDummy, right? If I say get, and then I got these options, and then I will call my data frame inside here, Titanic df, make sure I got the right one. So Titanic df at sex, for example, right? And then I will, it will change the sex column to 0101, but we need to drop one of them to avoid collinearity, right? So Python has that method called drop first, right? So drop first equal 1, because you will have 2 columns. one columns, if one column is 1, the other column will be 0. If the other one is 0, but this will be 1. So you will have 0, 1, 0, 1 in both columns. So one column can actually represent both of them. Because in that single column, if you see 1, that means it is true in that column. Let's say female. If you see 0, that means it's a male. In the single column, you will have a 0, 1, 0, 1, 0, 1. So let me see if I can do that. So 0, 1, below that, 0, 1, 0, 1, 0, 1 in the single column. So 0 mean male, 1 mean female, for example. Right. So that's F. This one mean male. So in the single column, instead of having this, and then that, instead of having 2, you drop just one of them. Right. So that's what this thing is doing. So let me take this out before it run error. Create error message here. So we're gonna say drop first equal true. Right. So that's our new variable. Now the second variable is embark. Right. So I will call the lowercase e to make a difference. Embark equal same thing. I'll just replace sex by the so PD the get dummy, and then our data frame at embark. So it's a series. Right, so embark, and then again drop first equal true. Drop first equal true. That. So we got these two variables. Now we need to concatenate them to our data frame. Right. So we're gonna say our Titanic data frame is equal to our pd.concat. Right. So we want to concatenate our Titanic data frame, right? And then our sex, and then our embark. So we're gonna do it by column. So you do Titanic data frame this column, and then you will add sex after that, and then embark after that. So Titanic DF, sex, and then the last one is embarked. That's it. Right. So now we need to say by axis. So let me put here axis equal 1 by. This means we want to read by column. Because I have a list of data frame here, I need to put them between square bracket. If I don't do that, get an error message. So now if you look at it, our new Titanic DF, if you look at the head, get this. Okay, I got a message again. Okay, that's not me. Okay, so this look better, but from now, I don't need this embark with capital E anymore. I don't need this sex with capital S anymore. So we need to drag them, right? Because we got a dummy variable representation of them, right? So let's do that. So Titanic DF, right? That's drop again. So here we got 2 of them, sex, and then embark. So now embark, and then axis equal 1, in place equal true. In place equal true. So now let's look at the head. Our Titanic DF, that head equal this. Okay, doesn't look bad, right? So let me check if there are some still missing stuff in there. So Titanic DF that is an A, that sum. Let's look. Okay, age. Oh, yeah, I did that below here. I did the age thing below here. So that will take care of it. So only the age got 177 thing missing. So we take care of that here, right? We replace the missing age by the mean age of the class, right? The mean age of the class. So what's the name again? Oh, sex. Yeah, I don't have that. This is the that. This is lower. This anyway. I don't need this anymore because I dropped these. There could be up there. Let me take that out. That variable is gone. Survivor. So this should be before I drop them. Let me cut them here. Put them before dropping. Yeah, somewhere here. Before I drop them, for example. Here. Before dropping it. Because once you drop it, you can all use it. Take this out. Yeah, so after this, we look at our Titanic DF now that head. Yeah, I think this is ready for the machine. Let's see if there is any noise state is an A. That's some of all the NAs. Oh, what happened? It didn't change my age. Oh, the big age is still there. I thought I dropped it. Didn't I drop it here? No, I didn't drop it. So I'm gonna drop the big age, right? Because we don't need that. The small age is enough. This small age got nothing in there. So I'm gonna do that here. So you see, we did a lot of dropping. So that drop this age, right? Axis equal 1, in place equal true, right? And then I will run this again.
In places
Oh,
misspelled.
yeah, in place. Right, so let's look at that. Now, no noise, right? Our data is perfectly clean. Now it will be, fit into our machine.
Dr. Musa.
Yes.
Yeah, I saw when you create a dummy variable for sex, you put sex, but it's showing male and so it's not showing. Okay, it looks like
when you see 1 is male, 0 means female.
Yeah, but you put the name sex, right? You didn't put the name dummy male. So how they came up male?
Yeah, I didn't choose that name.
Oh,
yeah, it is automatically chosen.
Automatically chooses. Oh,
yeah,
okay, because okay, same for okay, that's why. Okay.
Yeah, same for cabin embark.
Embark. Oh,
yeah, embark got SAF, SC, and then stuff like that.
Yeah, I know. I saw this one. You put this one sex, but embark. So it's a name different male, male and Q. Oh,
these two for embark, because embark is a categorical column that has three possibility.
Oh, 3 possibility. Oh, that's why. Yeah. Oh, 2 dummy. Okay. For sex is for male.
Yeah, sex is 2. So you give me 1.
0 and 1. Oh, good. Oh, okay.
Yeah. So this data is really not there, but this one, see, no noise, right? Everything is just numbers also, right? If you look at the info, we don't have any categorical data anymore. There shouldn't be any object. If there is an object, make sure that is taken care of first before you fit into your machine, right? No objects here, right? Okay. Any other questions?
So yeah, how they pick up the coding?
Huh?
How they pick up coding for the sex and the cabin? Is any just they randomly pick up?
For the cabin, if you look at it, I think they randomly pick up. I don't have any. I didn't input anything for it.
It's like a
Just,
embark.
yeah, just came out like that. Yeah.
0 and 1.
Right. QS.
QS. So
yeah.
0, 0 is the reference.
I think there must be a literature. It might be linked to the cabin name or stuff like that. And I think, yeah.
I said,
if you read the data description, yeah.
Yeah, the structure. Okay. Thank you.
No problem. So that we don't have any objects, so we are ready to go. So this lecture is about logistic regression. So we need to import it. Before that, we need to divide our data set into 2. So training sets and test set. We're gonna train the model on that big part of the set called training set. Once the model learns from it, then we're gonna test it on the data that it didn't see, the test set our model doesn't see. And then once the model tests it out, we're gonna see how good the model was. And then we're gonna print out the confusion matrix that we discussed earlier, and to see how much we got right, how much we got wrong. Okay, so let's see. So we need to import train test split. So from sklearn, we'll say from sklearn, right? Sklearn is here. Attack sk and then sklearn command. That model selection, we're gonna import train test split. Model selections, yep, right here. All right, sklearn the model selections, no selection here. From that, we want to import train test split. Train underscore test split. Let me take this out. Train test split. All right. Train underscore test underscore split. Now I'm gonna split my data into training set and then test set. All right, so by convention, X train, capital X train, X will be divided into X train, X test. Y will be divided into Y train, Y test, Y train, Y underscore test. So is equal to our Titanic data set, right? We're gonna call the train test split that we just imported. Let me write a train test split. Right. That will be splitting our Titanic DF. So X will be everything except our survive column. This will be our Y. That's our target, right? And then the rest of them will be the predictors. This is the target here. So we're gonna say X is everything except of the survive column. So I'm gonna, what is that? Right here. So is our Titanic data frame, right? That drop. So you see it dropping again. Drop. Okay, we're dropping our survive. Survive didn't complete, okay. So we drop that. So that's our X value. Now the Y will be our data frame evaluated at that, right? Our data frame evaluated at survive. So that series will be our Y value. So let me set how I'm gonna drop this. I wanna drop the entire column. So I will say axis equal 1. So that drop, survive. In fact, I don't need a square bracket here because I only got 1, right? So axis equal 1. Axis equal 1 here. So that means drop the entire. Now, after I drop down, let me come here. I wanna say the Y is a Titanic DF, evaluate our survive column. Survive. So how I want to split this. So I want 80% to be train and then 20% to be test. So to tell your to tell that to Python, you will say test size equal 0.2, for example. That means 20%. That's a test size, and then 80% will be training size, right? And if you want to get the same result like me, you can do this random state, right? Random states, random underscore state is equal, let's say 3. Then if you run this, you and I will get the same thing. Now I want to display the size of this thing to see, to display the from IPython, that display, I want to import display. So I did that. Then I want to use that display. I want to say display, hey, display me this thing. I want to know the shape of a X train. So X underscore train, train that shape. And then Y underscore train that shape. I want to do the same thing for the test. So I change this to test. Change these to test. Yeah, so let me run that. Let me make sure I got my display. So the X train got 712 rows, 8 column. The Y train got 712 rows, 1 column. So you see they got the same number of 4 rows. Similarly, for the X test and Y test, 172 rows for X test, 8 column. For the Y test, we got 179 rows, 1 column. Right, so we're good. So now we split our data into training set and then data set. Now we need to import our model now. Do I have a message? Okay, Slack informations. That's
So,
now.
this is 712, comma, that means because here 712, 8 rows, right? But here only 712 column.
Yeah, just a series. Just a series, 1 column series.
1 column.
Yeah.
For the survive. No. Yeah. Okay, but no 1. It's not showing 1. Just
yeah, because it's just a series.
Series. Okay.
Yeah. Y test and Y train are just series. Okay, so now building our model, we need to import it first, our logistic model. So we go to scikit-learn the model selection again. We're gonna import logistic model, right? From sklearn, sklearn that model selection, model underscore selections, import logistic. This is a capital logistic model. Logistic regression. Right. So now then we can instantiate this thing. What did I mask? Let me see. Logistic regressions. Logistic. What's wrong?
Should it be from the linear model instead of model selection?
sklearn that yeah, you're right. Linear logistic, yeah. sklearn the linear model. You're absolutely right. Thank you. Right. So that
Why? Because it's a logistic, but you're importing linear. It's a subtype of that one logistic from sklearn.
Yeah, sklearn, that linear model, content logistic model. Logistic model
Okay.
is in there.
Okay.
Yeah, is in there. So now we can instantiate this. We can call, this is the name of our model now. We can call it log model, log logistic for logistic model equal to this logistic regressions, the object here, logistic regressions here, right? So now we're gonna feed that into our, let me run it. So we call our logistic model, log model, right? That fits. We're gonna fit it into our X-train, Y-train. Right. Okay, I'm not worried about this this thing, warning. So now this is quicker. Like I said, running a model is just like 5% of your job. You just need to know how to call the model and then apply it to your thing. So what message is here? Okay, that's not me. Okay, so now I train it. We just train our model to that training set, right? So now let's predict it on the test set. So predictions right here, not down, prediction down here. So let me delete this. So prediction first.
Why you don't need to worry about this, the warning sign?
Huh?
Why you don't need to worry about this, this warning sign? It's not a it's
user usually is about conflicting or stuff like that. I don't have a very let me see.
It said fail to converge status 1.
Fail to converge status 1. Where you see that?
This
okay. So page 444 conversion there. Yeah, I think this might have to do something with some update or version of Python. You will see. I don't worry about it. I think there is a way to get rid of this warning. I forgot, but it's not that important, right? Yeah.
Thank you.
For our model.
And also just to comment, you see that I think the message is also very clear that it didn't converge. The converging basically means you've hit. Remember, if you one of these lectures, they talk about the goal. The aim is that your accuracy or your error will plateau. I mean, yeah. So your accuracy will keep going up and then to plateau, and then at point of plateau, if you haven't hit the number of iterations, because it has to run through a couple of iterations to hit a plateau. If it hasn't gotten there, it's just FYI. It's just information to you that, hey, you know what, I've reached my limit, but you haven't gotten to the plateau yet. You need more iteration to go. And you can Google that too.
Thank you.
Okay, sure. Okay, sorry, Dr. Musa.
No problem. So now, model prediction, we're gonna do prediction also. I will say prediction equal our log model applied to the X test now. So we are using X test to tell what the Y will look like, the Y test, right? So X test, right? So if our model does very good job, this log at X test should be almost identical to the Y test. And the difference between this prediction and the Y test is the error. right? Okay. So that's our predictions.
Can you say again, what did you say? If
Yeah, our model,
Mhm.
right? If it does a good job, then this prediction should not be far away from the y test. It will be almost equal to the y test. You remember we got x test, y test?
Yeah, X test for the Y test. What is the difference? X test and Y test?
So think about this as a function. Our model is a function. So f of x test should be equal to a y test.
Y test.
Okay.
Okay.
Yeah, let me see if I can. Yeah, so like this, if you think about it as a functions, right? Our model, let's say, is a function f. So f of x underscore test
Mhm.
should be equal to, if we did, or it get close to, right, our y test. Right. So let me.
So Dr. Mausa, I have a question. So basically the numbers up above, right, that you ended up getting for Y test, I think it was a little bit above, have to match the prediction, right? Those numbers like the 712 or the sets, I think.
No, this is just the number of rows.
Oh,
Number of rows, number of, yeah.
Mhm.
So let's say in the Y test, let me put this between curly brackets. 1 second.
Thank you.
Yes. Okay, so this is what I said, f of that. So let's say your x test, let's say for x test equal 0 to, this is just an example, right? It could be anything here. You remember our x test, these are our features.
Features.
Right. So yeah, those are our features. Now we want those and then our y test was let's assume that our y test f of y test was like here 4, and then here the y test was here 20, just example. Here our y test was here 15, and then here our y test was, I'm just giving random number here, 23, and then here our y test. So here this is y test. So y test here.
So it's not a survival thing, right? White one, it's not the outcome. Yes, no, 0,
Is
1.
the outcome. Y test.
Yeah, that's
Y
what.
test should be equal to the outcome. Our prediction is the outcome.
Outcome, good.
Right?
Yeah. That's
So yeah, so our outcome. So I will put here prediction. Our prediction is here. Prediction. Our prediction should be close to that, right? Should be equal. If our prediction here is 3, that's not too bad. If our prediction here is 19 or 21, that's not too bad, right? Very close, right? And then here we spot on it 15, and then spare we got it also. That means the error is smaller, right? When we say it survived, then in fact it survived. When it say it didn't survive, then in fact it didn't survive, right? So the prediction here and the Y test should not be too far away from each other.
Yeah. Okay.
Right.
Thank you.
No problem. So clear now. Okay, so I don't want this to be a markdown cell anymore. Change the cell to a code cell. Now I want to use my prediction as a log mod that predicts, right? We gotta use predict. Right, just predict. Now X test. And I'll run this. So this is our model saying that, hey, the output looks like this. Now, how do you know we get it? We get close to it or we get far away from it? So we call our confusion metric to check, right? So we can say from sklearn that metric. So we're gonna import we can import classification metrics also, classification metrics report, and then confusion matrix, right? So now, because we discussed confusion matrix, let me print that first. So I will say print. I want to print our conflicts at our y-test and our predictions, right? Y-test and predictions. So confusion matrix that is taking on our y-test and our prediction here. Right. And then we'll analyze. So this is what we got. What? It's not that bad because actually, if you look at what is the last thing? I think we can normalize this. You see, this far column seems to be greater than any other. These are 0, 1, 0, 1. Far and edge column, right? One can make it better by normalizing the data. I didn't normalize it, but let's look at this thing. It says we got this. If we say true positive, so 84 of them. This is true negative. This is true 54 true positive, right? So we said 16 were no, but they were in fact true. So we missed this. We said 15 were yes, but they were no. So we missed 25, right? 25 false or negative, 16 false positive, right? And this, if you want to know the precision, for example. So the precision, actually, let me just run classifications matrix. That will tell us about the precision, the recall. Here, I will call classification report. Classification report, that's it. And then run this. So I got the precision here. On the zeros, didn't survive, we got 84 of that. F1 score, this is not bad, right? So F1 score, we got 72. I see some model that don't go be, above 50% for F1 score, right? So we have a F1 score that is 70%, right? The precisions, do we know what precision is? I think I have precisions. Is that clear? Precisions and F1 score. Is that something clear? Does it ring?
So if the model is not good, what can you do?
Oh, so like I mentioned, let me go back to my logistic model here. So here, if you look at our data frame, I will normalize it. And there are many ways to normalize it because look at the far column. It got more weights than any other columns. You see, yes or no? More weights. So, so let me put here 50 of them. You see, some of them get bigger. Oh, what did I do? Did I erase anything? Oh, I'm trying to drop it again. You can't drop twice. Okay, so let me take this out of here. Right. Clear these. So cell. Clear that. Current cells. I can just leave it there. So clear that. So here, right, you see the far column got more weight. The value are bigger, even the edge column also. So if you want to perform it, that's one thing to do, right? That's one way, you know, to make it better. In fact, I would encourage you to do that. Did I share this with you? Let's take 10-minute break. Okay. John said, let's take 10-minute break. We come back. So 10 minutes from now, 55. Okay. All right. So that's your logistic model. Again, you can make it better by normalizing and then by, you know, playing with other stuff. So I'll see you soon at 12:55, 5 minutes to 1. Okay. John here. Okay, so the next thing that I want to mention, William, I can start it, right? Okay. All right. So the next thing.
Yes.
Okay,
Sorry,
okay.
I have my mic on mute.
No problem. So like I said, this model can be improved, right? So you can normalize it, standardize it, and then see what's up, right? So decision trees, right, is another type of classification model that will allow us to predict, right? Think about a scenario where you play soccer, right? Like I like to play soccer. You play soccer every Sunday or every Saturdays, and you invite some friend to come over. So based on the conditions, like the temperature, what time of the year is it, signing, raining, is it windy, right? So based on those, the person might show up, right? So let's say you record those informations. It was signing this day, the temperature was 70, the wind was too bad, and then he showed up. It was sunning, but the temperature was like 102. It was also windy, and then he didn't show up, right? So, and so on, right? So based off those informations, you want to know if he will show up next time. So that time, you know, the weather, you know, the temperature, you know, the look, is it cloudy, raining, signing, snowing, you know, all that. So decision tree will allow you to predict such a scenario, whether or not your friend will show up based on historical data. I do want to warn you though, our decision trees are not that good in classifying because of the high variance. I personally would choose random forest over decision tree, right? So people can argue, but that's what I noticed. You got high variance on it. And anyway, I don't want to go too much deeper in that. Again, if you're interested in learning about the mathematical concept about it, you can read the book called Introduction to Statistical Learning. So that's a good reference, you know, to go by. Right. So now let's go to our very, very first decision tree model. So I want to import libraries. Always, I want to import pandas or speedies, right? So pandas, speedies, and then NumPy also as NP. I want to import matplotlib. Maybe I'll do some import matplotlib that pyplot plot as PLT. I want also Seaborn import Seaborn as SNS. Yeah, and I want this online, matplotlib inline. Just in case you're not using Jupyter Notebook, you need this matplotlib inline, right? And that's it. As NP, what's NP? Did I say import? Import NumPy as NP. Import Seaborn also, not Simport. Okay. Matplotlib inline. Yeah. Okay, so we got this. And then to demonstrate today's lecture thing, I'm using a data set that I shared with Nana. I think he will post it on GitHub. So I call that data set tree data. So I'll say df is equal our pandas that read underscore is a CSV file also. So I'll choose the CSV one. And then here is tree underscore data.
What is parcel matplotlib inline? What does it mean?
It will allow you to print out your plots.
Oh,
Right. I'm using Jupyter Notebook. I don't need it, but if you're using another thing, this is for plotting, printing your plots, your graph. Right. But if you're using Jupyter Notebook, you don't need it anyway. It will just show up. So tree data is a CSV file, that's CSV. Right. Okay. So now, like last time, you can look at the head of that data set. So df that head.
Dr. Mausa, really quickly,
Yes.
where can we find that tree data set?
That tree data set, I think I got it from Kaggle or Quandle. You know Quandle? It's been a long time. I used it for my class at Howard. It could be one of them, either Quandle or UCSG. You know that too? They call it UCLE. I get data from those three sources. Quandle is one of them. Kaggle, for sure, Kaggle. I got a message. Yeah, UCI. Yeah, UCI. Very good, William. UCI. It's been a long time. I have this data. Either one of them. Okay, so let's look at the head. It looks like this, right? Not that bad. So here, what should be our target? We got absent, present, absent, present. Obviously, that should be our target, right? Right. Okay, so now let's do some EDA, right? So pair plots will allow us to see some relationship between our different features. Because we import Seaborn, we can just do that, right? So SNS, I import it as SNS, so as a SNS that pair plot, SNS that pair plot, and I will call our data frame. I call it DF, and then hue equal, we can pick hue equal this disease, chi capital, I believe it's capital, chi for CC, all right? And then our color, I will pick Pyatt equal HT, for example. Right. So we got SET1, that's one of them. You can change it to SET2. Now let me see what Pyatt is PA. Right. So this is our pair plots. As you can see, some of them don't have any relationship with each other, but you can change these also. Let me see. With this guy, I did this in the introduction to Python data too. I went through these different Pyats. So if you want to know how to play with this color, you can check that. Cool, warm, stuff like that, HT3, right? All of those names. So anyway, so we have our data set. Let me check the size before I split it. I want to look at the size of this data set. So I will say df.shape. The shape method will return the size. Tuple has no update. No, it's a that, right? So it's a small data set, right? So 81 rows, 4 columns, right? So again, we can do 80-20 or 30-70 right here, right? So again, to split it, we need to call our scikit-learn, the model selection. We're gonna import train test split again, and then we're gonna use it to split our data set into training set and then test set. So let's do that here because I say here. So I said from my sklearn that's model selections. Yeah, sklearn the model selections, import train underscore test underscore split. Right. So we got that. Now we're gonna say our x, right? X equal everything in the data except the disease column. So is our df that drop. I want to drop that thing called kyphosis. And then axis equal 1 again. In place equal true. In place equal true. So you see, we're doing the same thing over and over again. So that's my x. And I want y to be only one column that contain the disease column. So y equal our df at kyphosis. That's it. So we know our x, we know our y. Now we can split them. Did I split it? Kyphosis. It's not that. Kyphosis. It's not how we spell it. Let me look at the head here. And spelling problem. Oh, did I drop it already? Oh.
How it is dropped?
Yeah, I dropped it here. No, I didn't drop. Let me look. So it's here. And here. I didn't drop it. Let me put this in square bracket, for example, maybe. I didn't drop it, yeah? I want to drop it here. Yeah, maybe that was a problem. No. It didn't exist. So let me do this. Kernel.
Hello, Dr. Musa. Your voice doesn't come through for me. I'm not sure if others are having the same problem.
Oh, okay. Yeah, I was muted. My God, I was muted.
Okay,
I was
thank you.
muted. Yeah, I
thank
was
you.
muted.
Yeah, thank you.
Wow, thank you. So I think I was clear the wrong thing. Let me see here. Anyways,
Somewhere there, yes.
Yeah, it just so let me do this step by step. We did it earlier, so the hair is there, kyphosis is there. See, I didn't drop anything. I just did a plot. In fact, let me skip that plot, because I need some space. Okay. Now we are here, and he's saying I drop it. I didn't drop anything. Let me say y equal this. Our df at kyphosis. It's kyphosis. It's saying that drop it. So let me see here. It shouldn't be here. You see, done. Oh, maybe before I drop it, I assign it to. Oh, I see why. I shouldn't do this. Because I assign it to X, that's a problem. If I assign to X, I don't need to say in place equal to, because if I say in place equal to, it will no longer exist in DF. Well, I think this is a good lesson here. If you want to set it to a variable, you don't need to set in place equal true, right? If I say in place equal true, these chaoses will no longer exist. They will be gone. And then something that is not there, I want to assign that to Y. That's the problem, right? So in place is not equal true there. You will see everything will work now. Right now, no problem. Right. Do not set in place equal true if you want to assign the chain to a variable. Now, decision tree. Again, we're going to import, our decision tree first. So from scikit-learn again, from sklearn data tree, we're going to import our decision tree classifier. Import decision trees classifier, right? Decision tree classifier. So capital D, capital T, capital C, classifier. And then we're gonna instantiate that. Somebody got a message for me. Let me look at that first. Yes. Okay, so now from sklearn.trees, import decision tree that classifier. What's the message? sklearn.tree. Import decision tree classifier. Double F. No, it's one F, classifier. Cannot import name decision tree. What?
Decision is not spelled correctly.
Oh.
I-O-N.
Yeah, there is an I there. I missing. Very good. Now, see, Python is speaking. Anything it will not work. So D3, I'll call this one decision tree, is equal to this instant. In fact, let me copy it so that I don't want to misspell it again. Equal this instantiations that. Now, oh, when I import train test split, I didn't split our thing yet, right? Did I split? Train test split, we did not. We gotta do that here, right? So
yeah,
you gotta do that here. So X underscore train, right? X underscore test, and then Y underscore train. Oh, lowercase. Y underscore train, Y underscore test equal our train test split. Train test split of our X and Y, capital X, lowercase y, and then test size. Test size equal what? Test size here, put 30, so 0.3, 30%. That's it. So now splitting these. Again, you can look at the shape of every one of them, right? If you want. Now we have it. We split it. We can use it now in our model. So now it's time to train this model to this X train here and then the Y train. Right. So X train, Y train, we need to train it now. Anybody know? What should we do next? I want to train. Like in our logistic regression case. I want to train. So our model is D3 here. Remember the code? The model is D3. And like I'm saying, I want to train the model right on our X train and our Y train. What should be the code for that? Like in the logistic case, it just that you will call your model D3 that fits, right? So you want to fit into this thing, right? Your X train, X underscore train, Y underscore train. It's like you have a dot that looks like a parabola, and you are fitting a function that will capture those dots, right? And if a function that captures those dots, that function becomes your model now, right? And then Python is so powerful, it did it in a second, right? So we just fit it in there in our X train and Y train. Now, next thing is to do some prediction and evaluations. D3 that I didn't say D3. I didn't run this maybe. I gotta run it first and then feed it here. Yes. So now we train it. That's it. You just train our model to those data sets. So now the next thing to do is to do some prediction and some evaluation. So same thing like our logistic case. So you will say predictions equal, right, our D3 that predict. So we want to predict X test, X underscore test. Again, this prediction should not be far away from our Y test, right? The closer they are, the smaller our error will be, right? But if they're too far away, then the error become bigger. So now we just predict. Now, how do I know these predictions were accurate? We're gonna check from sklearn that metric. We want to import classification metrics and classification report and confusion metrics, right? And then we want to print them. So print classification metrics, a classification report at our Y test and then our predictions. Y test and then prediction. Let's see, I think I have S on it. So, right, so we accurately, absence, we accurately predict that 82%. This model can be improved because you see the F1 score is lower. Could be improved. So we can also look at the instead of a classification report, we can use a confusion matrix. Confusion matrix. Right. That. Wow. So we only got 6 wrong. 4 plus 2, we only got 6 wrong. And then we got 19 right. 19 over 25. What's 19 over 25? 19 over 25. So that's our accuracy. 25. Yeah, 76%. Yeah, this model can be improved. It could be improved. So now, let's visualize the decision tree. So here, I really don't. I don't encourage you to, try to understand too much how to visualize this decision tree. Usually, you don't have to. Right. Throughout this course, this will be the only time you'll be printing the decision tree. And it does come with price. If to be able to visualize your trees, you need to install graph fees. It doesn't come, Python doesn't come with it. I think I have it here. Graph fees, this thing, graphease.org. Let me see if I can share my whole windows. Can you see this web browser? So if you want to be able to visualize your tree, you come here and then you click on downloads, right? And then you install it, and then you will be able to. But since this was our first time to talk about decision tree, I was like, maybe we should visualize it. Right, and I'm not gonna go too much into the mathematics. Beyond it, where is my decision trees? Yeah, we are here visualizing. So once you install that, you need to import this, right? I'm pretty sure the installation for Mac and Windows will be different. So I'm using Windows. So if you're using Windows, you need this library, you need these also, right? And I want to talk about something called Gini index. You see Gini index everywhere, Gini. I think I will just explain that because I would advise not to go too much into the mathematics behind this. So this is our trees. You will not be able to print this if you don't have the thing that I just mentioned to you, right? So let me talk a little bit about the Gini index, and then and normal math. So let's see. Okay. Here's my pencil. Okay. So I want to grab one of these PowerPoint. Let me see, for example, I just need one blank page. One blank one. Yeah. So here, the Gini, those Gini impurity come from here, right? So you have, let's say you have this thing. Come on. It looks like I can't write. Let me see if I can write. Okay, but I don't want writing here. So let's say you have these people who like coffee, right? Coffee here. And you got a group of people, and some of them say yes. Some of them say no. no. Right. So among those who say yes, oh, okay, I'll try my best. So among those who say no, you want to know if they like soda, for example, let's say Coke instead of coffee. So for yes, you got 1. For no, among those people, you got 3, for example, right? And then for those who said no, we don't like coffee, you got like here, for those who said no, you want to know if they like this soda. So among them, the yes, oh, let me see if I can delete this. Okay. So the yes among those are 2. And then the no is just 1. Right. So how do you find the Gini index? The Gini index will tell us how well our tree branch will split it. Right. So how do you find the Gini index? Or the Gini impurity? Let me put it this way, because Gini index is an economics term. Right. So the Gini impurity here is equal to how many people we have here? We have 4 people here. And how many people we have total? 7, because this is 3, 6, 7. So the Gini impurity for this left leaf, so I'll just call it GL, is equal to this 3 plus 1 is 4 over the total number of things. This is 3, this is 3, 4, so 3 over 4. 4 plus 3 here. Now, multiply by 0. So multiply by the Gini index of the left 3. How do you get that? So the Gini index of this left thing is equal to, of this left leaf, so I'll just say LL is equal to 1 minus the probability that these people like Coke, the left leaf like Coke. So how many people we have there? 4. How many people like Coke? 1. So 1 minus the probability square. So 1 over 1 plus 3 square minus the same thing here. People on this side, right? So we got 3 people down there who do not like coffee at all, but 2 of them like Coke. So minus 3 over 1 plus 1, 1 plus 3 square. Right. So now the left leak, because these are not in the left leak, so minus the probability. So if you do this algebra, you get a 0.375. So that multiplied by here 0.375. Oh, I don't know what is happening. Now that's that. Now plus the weight of the right leaf that way. How many people we got? 3. So 3 over 7. So 3 over 4 plus 3 again here. Now multiply by the Gini impurity of the right leaf. So right leaf Gini impurity, that will be equal to 1 minus 2 over 1 plus 2, or 2 plus 1 is the same thing. Now minus 1 over 2 plus 1 here square. So if you do that, you get here 0.444. So multiply here by 0.444. So if you look at the tree, you will see this. So you do this algebra, you will see that the Gini impurity is equal to 404. Right. 0.404. So that's what Gini is about. So some people like to use how do you call it, entropy, but Gini index is famously used. Again, I don't want to go too much in detail into the math part of it. If you want to have more details about this introduction to statistical learning is a good reference, right? So that's why you see in my thing here, everywhere you go, you will see Gini index, or Gini for shortcut. Let me close. Well, I can close this. Okay. So that's why you got those impurity here, those Gini impurity here. My Zoom. Can you see my thing? My Zoom got smaller. How can I make this one bigger? Okay, yeah, now it's bigger. Yeah, so right, that's this. So now, before the time is over, we can discuss a random forest. Random forest, I personally trust random forest compared to decision trees. Like I said, the variance can be higher in the decision tree here. Random forest is a collection of decision tree. So it will decrease the bias, the variance in there, right? So the bias is higher a little bit compared to the decision tree. So now we have a random forest in scikit-learn. We imported exactly like we did with our decision tree. We imported, right? But it does take an estimator, 100. So for example, we instantiate it to this. Random forest stand for RFC, right? And then now, like in the logistic case, we need to train it to our X-test, X-train, and Y-train. We did already. Now we need to predict it. This is the prediction part. We are predicting. So if you plug in this to our model, X-test to our model, are we gonna get exactly Y-test? If so, the confusion matrix will tell us. Right, the confusion matrix, when we print the confusion matrix, we get this. Look at this. This is much, much better compared to the decision tree. With the decision tree, we miss 6 of them. Here, we only miss 1, actually 5. They're not that much. Where was our confusion matrix? So here we miss about 6. So it's getting better. Here we miss only 5. We misclassify 5 of them. Let me look at my thing. My view on the screen is stuck. Really? Okay, let me stop. I'm gonna stop sharing.
Did anyone else have that experience? Like it just kind of was stuck on one part of the notebook?
I'm gonna share it again.
Yeah, it comes on and off.
Oh, really?
Yeah.
How about now?
Now I can see. Yeah, and it moves around. Okay, thank you.
Okay. So I'm saying that our random forest did much better job, actually a little bit better jobs than our decision tree. Again, Williams, you probably knows that random forest is much more efficient compared to the decision tree. Right, random forest is a collection of decision trees, so the variance will be smaller there as compared to these. So that's pretty much it about random forest decision trees. The logistic model, they're all classification models, right? And all the model that we discussed today can be improved by working further on the data, and then if you remember this, can you see these current slides? These are libraries, right? So this this processing can improve, your model accuracy also. right? Can improve your model accuracy. And yeah. So yeah, that's all I have for you today. Tomorrow I'm gonna talk about here nearest neighborhood and support virtual machines. And I have like 3 or 4 projects for you. So 1 project for almost, I think 4 of them. 1 project for every topic that we cover here. And then I also provide a data set. You know, everything is there already for you guys. If you have any question, feel free to email me. My email, I think I have it here. Oh. Okay. All right. So yeah, that's all I have today, Williams.
Yes, thanks a lot, Dr. Musa, and thank you all for making it today's class. I think John, Professor John would be joining us if he's on, but I don't see him. So yeah, so if we're done, then remember to sign up. Follow the link provided earlier to take the survey, and also sign in because otherwise you'll not get your certificate. And
yeah, William, I have an announcement.
Oh, good. Okay.
So there's a notice that was pasted in the Slack. I don't know whether you guys saw it, but I'm going to paste that same message in the. It's about getting your certificates. I think you have to do 80% of the assignment provided in order for you to get your certificate. Let me paste it in here again. It's in the Slack actually.
And what channel is it? Is it in the general, right?
It's in the general, yeah.
Oh, cool. Yeah, I see it now. Yeah.
So I just put it in the chat, in the Zoom chat.
Okay. Yeah. Thanks a lot. Yeah, I see it now. So I see both in the general and in the Zoom chat. Yes. So
just pay attention to the details on how to send your assignment in via the email address provided, and the subject area should be VADSTI for 2022 projects _ your first initial and the last name.
Okay. Yes, I see it now. I see some comments there as well.
Thank you.
Yes, please. Thanks, Nana, and thank everyone. And I think just remember to do the sign-in and also take the survey, and yeah, and then go to Slack and check. And Dr. Musa, are you planning office hours today or tomorrow? Are you planning office hours?
Maybe tomorrow.
Tomorrow? Okay, cool.
Yeah.
Yeah. So thanks. We don't have anything, and then we do have office hours on the weekends. It's really very educative. It's amazing how much you can learn from students and from instructor. Last week was excellent. I learned a lot from Marietta, and so it's a two-way traffic. So please try and make it show up, and it's also an opportunity to create a network. So thank you very much, and check the office hours channel if you haven't done that already. And we'll see you tomorrow, same time tomorrow. If we don't have Dr. John online, then I think Stacy, do you have any announcement? Stacy? Okay, sure. So then I think we'll give you the rest of the day, and please try your hands on the exercises that Dr. Musa had shared with you. And I don't think that Abel is here as well. So I think we'll give you the rest of the day, and we'll see you tomorrow. So thank you very much.
Thanks, everybody. Bye.
Yeah, thank you. And then Nana, so I don't know if we end the session, that will end the record, right? Or do you have to manually stop the record? Okay. Oh, I think Dr. Jones. Yeah, I see John. Okay, I think once we leave,
it will
hopefully the
end.
session will end. And
Okay.
yeah, thanks a lot.
All right. Thank you.
Thank you. So, what? Work on. Oh, it says, are we going to post? Yes, yes. So things are going to be shared on GitHub, on the course GitHub. So the answer is yes. Yeah, thank you very much. Oh, and Dr. John is here. Yeah. So John, we're trying to. Yeah, I think Dr. Musa finished earlier. So.
Okay, so then we'll continue tomorrow. Rabka ahead to answering some questions. So go ahead with.
Okay, so yeah, so thank you, and I think we shared everything we need to share. Nana shared the announcement on Slack, and there's also the sign up and the survey. And yes, things are going to be posted on GitHub. So that's all we have. Thank you.
Okay, so if there are no any questions, then we'll meet all of you again tomorrow, same time, and continue with the classification modules.
Thank you very much.
Any TA sessions this afternoon?
No, in fact, Dr. Musa said tomorrow.
Tomorrow, okay.
Yes, please.
All right.
Okay, and then we have one on Saturday as well. Saturday is 5 to 7. Yeah. Thanks a lot. Okay.
All right. So